This is Wylock 3rd grade worksheet lesson 28. Fill in the blanks. So for the first problem, we have 320 plus blank equals 1000. So we need to find out how much we need to add to 320 to get 1000. And the way we do that is by taking away 320 from 1000. So let's write that over here. And then we subtract normally to find the unknown. So 0 minus 0 is 0. 0 minus 2, we have to take a 10, so this becomes a 9. So 10 minus 2 is 8. And 9 minus 3 is 6. So our missing number here is 680. Now you can do the same thing for all of these problems. So for the second problem, we have 503 plus blank equals 1000. We have 0 minus 3, which isn't enough, so we have to take a 10. So this becomes a 9, and this also becomes a 9, and this becomes a 0. And this becomes a 10. So 10 minus 3 is 7. 9 minus 0 is 9. 9 minus 5 is 4, and 0 minus nothing is 0. So our missing number is 497. Blank plus 549 equals 1000. We're going to do the same thing again. I'm going to write it right here. 1000 minus 549. We have to take a 10 from the tens place. So this becomes a 9 and a 9. 10 minus 9 is 1. 9 minus 4 is 5. And 9 minus 5 is 4. So 451 plus 549 equals 1000. Now you should recognize that all these equations are related. So 1000 minus 549 equals 451 is related to the addition equation. 451 plus 549 equals 1000. They're the same fact, but they're expressed in different ways. They're written in different ways. So for the next problem, we have 358 plus blank equals 1000. We'll use the same thing. 1000 minus 358. Take a 10, so this becomes a 9. 9. This becomes a 0. 10 minus 8 is 2. 9 minus 5 is 4. 9 minus 3 is 6. And our answer is 642. Let's do one last problem. Blank plus 491 equals 1000. So we have 1000 minus 491. Take a 10, so this becomes a 9. And this also becomes a 9. 10 minus 1 is 9. 9 minus 9 is 0. And 9 minus 4 is 5. So our answer is 509. Let's move on. Fraction drills. Solve each fraction. So here we're just adding fractions. So 5/15 plus 7/15. So in order to add fractions with the same denominator, we simply add their numerators and keep the denominator. So we know our answer is going to be something over 15. Now the numerator is going to be 5 plus 7, which is 12. Now we learned a few lessons ago that we can simplify fractions if they have the same factors. So in this case, 12 has a factor of 3, and 15 also has a factor of 3. So when we divide both sides by 3, so 12 divided by 3 is 4, and 15 divided by 3 is 5, we get 4/5. And so that's our final answer. The next problem is 1/10 plus 3/10. Again, we're going to add the numerators, which is 4, and we keep the denominator of 10. Now we can simplify this by dividing both the numerator and the denominator by 2. So 4 divided by 2 is 2, and 10 divided by 2 is 5. So our final answer is 2/5. Next problem, we have 2/18 plus 4/18. That's going to be 6 over 18. Now you can see that both sides here can be divided by 6. So 6 divided by 6 is 1, and 18 divided by 6 is 3. So our final answer is 1/3. Next problem, we have 1/14 plus 3/14. 1 plus 3 is 4, and we have a denominator of 14. Now to simplify this, we can divide both sides by 2. So 4 divided by 2 is 2, and 14 divided by 2 is 7. So our answer is 2/7. 5/20 plus 7/20 is 5 plus 7 is 12. Keep the denominator of 20. Now we can divide both sides by 4. So 12 divided by 4 is 3. And 20 divided by 4 is 5. So our answer is 3/5. Next problem, we have 3/15 plus 5/15. So 3 plus 5 is 8. And our denominator is 15. Now this can't be simplified because their least common multiple is 1. That means that we can't divide them anything other than 1. So this should be our final answer. Next we have division drills. Solve each division problem. Now we're not going to actually solve each division problem, but we're going to express each problem as a fraction. So to do that, we have to take the number that's being divided. So for the first problem, it's 44. We're going to put it on the numerator. And for the denominator, we're going to put the number that's dividing the other number. In this case, it's 73. So since 44 is being divided, it's called the dividend. And since 73 is dividing 44, it's called the divisor. And this is how you express that in fraction form. Now for the second problem, we have 23 divided by 77. So 23 is the number being divided, or the dividend, so it's going in the numerator. And 77 is the divisor, so it's going to be in our denominator. So our fraction is 23 over 77. For number 3, we have 24 divided by 73. That's going to equal 24 divided by 73. For the fourth problem, we have 50 divided by 93, so this is going to be 50 divided by 93. It's very simple. So the next problem is 32 divided by 97. It's going to be like this, 32 over 97. And we'll just do one last one, 11 divided by 60, and that's going to look like this, 11 over 60. Now let's move on to the word problems. Number 1, Danilo's old extension cord is 9 feet long. He bought a new extension cord which is 5 feet longer than this old one. How long is this new extension cord? So we're going to take the original length, or the length of the original extension cord, which is 9 feet, and we're going to add it by how much longer the new extension cord is, which is 5 feet. So 9 plus 5 is 14, which means that the new extension cord is 14 feet long. For number 2, Gordon has 80 inches of ribbon lace and 15 inches of scotch tape for the cake boxes. He cut the ribbon lace into 40 equal pieces. How long is each piece of ribbon lace? So we're only going to worry about the length of the ribbon lace and how many pieces he cut it into. So to find the length of each ribbon lace, we have to divide the total length, which is 80, by 40. So that in fraction form is 80 over 40. Now notice that we can simplify this to 2, because when you divide 80 by 40, it becomes 2. And we divide 40 by 40 because it becomes 1. And that's 2 over 1, or just 2. So each piece of ribbon lace is 2 inches long. Number 3, Jacob's shoe size was 6 centimeters shorter a year ago. His current shoe size is 31 centimeters long. What was Jacob's shoe size a year ago? So we need to take the current shoe size, which is 31 centimeters, and subtract it by how much shorter his shoe was a year ago. So our expression is 31 minus 6, and that's equal to 25 centimeters. So his shoe size was 25 centimeters a year ago. For number 4, we have that Joe had a 6-foot length of wood and 2 hand saws to do a kitchen repair. He divided the wood into 3 equal lengths, but he only used 1 piece of the wood. How long are the remaining pieces of wood combined? So we're going to first divide the 6-foot length of wood by 3 parts. So 6, that in fraction form is 6 over 3. Now since both 6 and 3 are divisible by 3, this becomes 2 over 1, or just 2. So each piece of wood is going to be 2 feet. Now since there are 3 pieces, the total length of 3 pieces is going to be 6. But since he took away 1 piece, it's going to be 6 minus 2, which is 4 feet. So the amount that's remaining is going to be 4 feet in total.